These are really common questions. And to be honest, we mostly focus on perpendicular vectors. I will tell you about parallel ones, but most of the time they're perpendicular. Okay? So, the key thing here is, if you remember from last lesson, she says, optimistically, we get given this formula, yes?
Yeah.
That the cos theta equals A dot B. Do you remember the A dot B, the dot product? So that's where we multiply the, so if I was doing A dot B, we'd do P times S plus Q times T plus R times U, yeah? So that's the dot product, and then what did these lines here mean?
The modulus.
The modulus or length. Okay, and what do we do to find the length of vectors? Pythag. Nice. Okay. Yeah. Excellent. All right. Now the key thing here is that if we're saying that vectors are perpendicular to each other, it means that the angle in between them is 90 degrees. Yes.
Yeah. Oh yes.
But we know that the cos of 90 is 0. So that means that the dot product would therefore be equal to 0 if the vectors were perpendicular. Okay? That all follow, yes? So if the dot product is equal to 0, then they are perpendicular. And that's what comes up so often. It says so generally it will say prove that these two vectors are perpendicular, or given that they're perpendicular, find missing numbers. So they're the most common types of questions. So this example here says show that so-and-so is perpendicular to so-and-so. So remember, I like to write them as column vectors. Okay, so we're going to find the dot product of them. So to find the dot product, remember we multiply these numbers. So what's 13 times 2, Bella? Put it up? So I'm going to do, so I'm going to do the top two numbers multiplied together. So 13 multiplied by 2 is 26. And then we're going to do 23 times by 1. So we're going to add these numbers together. And then we're going to do 7 multiplied by negative 7. Negative 49. Okay, so then 26 plus 23 gives us 49. Take away 49 equals 0. Okay, now remember with show that question, don't just leave it like that, just make that final statement. So since the scalar product is 0, the vectors are perpendicular. Alright, okay, so perpendicular vectors, we know that the dot product is equal to 0. In a similar way, the dot product, if they are parallel, would be equal to negative times these two multiplied together. And the reason being is because cos of 180 is equal to negative 1. And so the negative 1 would come in here. Now, this is the reason that this one is not as popular or as common as the finding when they're perpendicular. Okay? So it's either, oh, I missed this one, sorry. It's either equal to this bad boy or this bad boy. Essentially, you're going to be finding the dot product. If the length of the two vectors multiplied together is equal to that dot product or the negative version of it, then they would be parallel. Okay? So as I say, not as fun, not as... So what you would do is you would... Okay, so you would find the dot product in the way we just did. Okay, so you find the dot product. You'd find the lengths of the two vectors using Pythagoras. You'd multiply the two lengths together. And if that was equal to the answer you got when you had the dot product, it means that they're parallel. If this, when you found the length and multiplied them together, it was the negative version of the dot product, also parallel. Okay, so it's one of those two options.
Coolio.
Tresbians?
Trade
Trade's good, yeah.
Okay. O for awesome. Oh my gosh, what is going on with this? I haven't got an example of that, obviously. When we've got vectors, if they've got numbers in front of them. Okay, so if you're trying to find the dot product of one vector and another two added together, you could use it like we would do normal algebra, so the distributive law. So we could find, if we're trying to dot product B plus C, we could do dot product of AB plus the dot product of AC. Yeah, this doesn't come up very often, but certain things we have to just cover with you, so we're like, we taught it to you, but it doesn't come up.
If
Are you
this
with me?
comes up, we may deny that you ever taught us.
You can deny it all you like. A dot B is equal to B dot A, so in other words, the order that you do it is not important, because we know the order we multiply things is not important. So this is going to be equal to each other. And again, if we've got a number outside, then it can we can join it with just one of the values. So this value here is only affecting one or the other of the things inside the bracket.
Why is that within the one up top?
Because we know that if we've got 2AB, this is either 2A times B or 2B times A. It's not 2A times 2B. Yeah? It's because this one's got a big plus in between, this one doesn't. Yeah? Oh, right, okay. I don't think there's enough space for all of these bad boys.
Let's just try it.
No.
No, I know, I don't think you've got a lot of space on your things. Alright, okay, let's have a go at some of
You
these.
can do it underneath. There's a lot of space on it. And there's a blank
Let's
page.
do it. Alright, it's I'm gonna stop this though and I'll